Hello class, Mr. Melly here. Welcome to the first video recorded for the data management course. I'm using a new app today. Tried another one, but doesn't seem to let me post videos, so hopefully this one will work a little better. So what I'm going to do with the first video is take up question number 13 from the homework in section 1.1. So let's see how this works. Section 1.1, that's pretty bad. Oh my. Yeah. Okay, that's a little better. So let's see, section number 1.1, question number 13. It's an achievement check question, which means you won't find the answer for that in the back of the book. Those are, good questions for me maybe to use for a spontaneous quiz or something, or just to check that you've done your homework. Okay, so it asks us, first of all, in part A, to construct a bar graph or a pie chart. I'll do both of those. It says with or without technology. So first I'm going to show you what it would look like if you didn't use technology. We need to do a bar graph, so here we go. Bar graph, we want to have a scale on it, and there are 4 different things that we have to graph. We either can pull out a red, green, orange, or blue counters. So I'm going to put little tick marks here for red, green, orange, and blue. And so, well, I guess we could just put a scale on here. 20, 40, 60, 80. Simple enough, right? This is kind of grade 7 or 8 math, I think. And I'm going to get fancy, and I'm going to actually graph it with the appropriate colors. But, just to be completely redundant, in case somebody is looking at this with a device that's not in color. What? I'll put it in color too. The green should go all the way up to 75, which I think will be a little shy of 80. How does that look? Not bad, I hope. Orange, let's see. Oh wait, I forgot to call that green. Just short form green. Orange is going to go up to 64. Little past 60 anyway. And orange and blue should go up to 39. Which is awfully close to 40. I think that'll probably do. How's that? Okay, so we've got our circle happening here, and we need to do a pie chart. So in order to do a pie chart, we either have to divide the different outcomes into degrees or into percents. I'm going to divide them into percents. There are a total of 200. If you add up all the different outcomes here, the different colors add up to 200. So what I'm going to do is I'm going to take 22 reds and divide that by 200. And 22 divided by 200 is 11%. So 11% of the data turned out red. And 75 divided by 200, well, that comes out to, what, about 37.5%. You don't have to write it in this form. You could write it as 0.375, but it doesn't really matter. 64 divided by 200 works out to 32%. And finally, 39 divided by 200 works out to just under 20%. We've got 19.5%. hopefully we'll find that if we add up these 4%, they'll add up to 100%, right? So we're going to do red first, so I'll use red. I'm going to start with 0 being about here. 11% should be a little more than 10. I've kind of loosely marked it off as being 10 degrees for each of these little notch marks. 37.5 degrees for green. Let's see, I've got a green pen here. So if I start my sector there, that'll be 10, 20, 30, 7.5. I don't know. Looks like when you add those two together, they should add up to a little bit less than 50%. So there's a new sector for green. And orange should be a little, well, should be 32%. So I'm going to say something like that. How does that look? Not bad, right? Because I'm color coding, I'm not going to bother labeling them, but you know, if you wanted to, you could label them as orange or green or red. Or finally, blue. Blue should be just under 20%, so it should be a sector just under 20% of the circle. There we go. So that's what the pie chart should look like. Because we've got it color coded, I'm going to avoid the redundancy of labeling it with a legend. So that's question A. Question A asked us to construct a bar graph or pie chart. Oh yeah, with or without technology. Hang on while I'll show you what I might do if I use that with technology. Yeah, okay, so never mind the technology thing. I was going to show you how I did it in Excel. I had a screenshot I wanted to share, but this particular app doesn't seem to let me include multiple pages or import screenshots after I've started the video. So maybe I'll figure out how to do that for a future video. Okay, so now we're on to part B. Determine the experimental probability of randomly drawing each color. So the experimental probability, something like this, I should have seen this in class. The number of ways that you can draw red. Oh, see, now that's just confusing, having that in blue ink. And I'm just a little too particular to leave it like that. So I'm going to say the number of ways that we did draw red, so n of r is how we write that, is 22. The number of total things which, well, either we would say which could have happened or which did happen, since this is an experiment, is 200. So that's how we write that. N of s is 200, n of r is 22. Another way of saying that is the number of outcomes which were red is 22, and the number of total outcomes is 200. We could then say the probability of an outcome which is red, experimental probability of drawing red, would be n of r divided by n of s. I'm going to be getting a finer point stylus soon, and hopefully my handwriting will improve slightly. I doubt it. 22 divided by 200, which, as we mentioned earlier, is about 11%. And we can do that for all of them. So here I go. I'll do it for green really quickly. Experimental probability of drawing a green counter is, well, should I skip the formality now? What the heck? N of green divided by n of s. N of s is always going to be 200, but green in this case is 75. So, sorry, n of green. So 75 over 200, and what did we say that works out to? 37.5%. So the probability of drawing green, according to this experiment, is 37.5%. And I'm going to start skipping some steps here because I'm getting bored. So let's see. Probability of orange is 64 over 200, which is 32%. And finally, the probability of blue is 39 out of 200, which is 19.5%. So that's part B, that's the experimental probability of drawing each color. Okay, so now moving on to part C. Use the results to predict the contents of the bag. Well, if we read the question here, it says that there are 10 counters in the bag. And so if there are 10 counters and roughly 11% and roughly 38% and 32% and roughly 20% of them are in each of those. Well, if you figure out what 11% of 10 is, that comes out to about 1.1 chips or 1.1 counters that are red. So 11% of 10 is about 1. Does that make sense to you all? And 30. So wait a minute now. So that would be about one counter that's red. See, and I wrote it in blue. Oh, I'm a bad person. Let's try that again. How's that? Better? Okay. And for green, we're going to say, 37.5% or 38% of 10 chips is about 4. 3.8. We'll say 4, about 4 green. And similarly, we'll do that for orange and blue. So when we add up these, we basically we expect about 1 red, 4 green, 3 orange, 2 blue. Fortunately, that does add up to 10 colored counters, which is how many we know are in the bag. So that's what I predict is how many of each color are in the bag. Now, question D. Oh, that's no good. I thought that was a highlighter. Okay, question D basically says, is it possible that your answer to part C could be incorrect? Well, I don't know. What do you think? These numbers are so awfully close to, 11% of 10 is so close to 1 red, and 38%, 38 is awfully close to 40, and 40% of 10 is 4. So I'm relatively confident. Now later in this course, we will actually have a way of measuring how confident we are, but what this comes down to is because we did 200 trials, the numbers are settling in around, it seems like they're settling in around, a pretty accurate prediction. If we did more trials, I might be more confident in this answer. But it is possible that the answers could be incorrect. I mean, if green was having a lucky streak, 75 of them were green, I think that's because there's 4 green in the bag, but maybe there's only 1 green and it just happens to get pulled a lot. With 200 trials, getting pulled 75 times based on, lucky chance, pretty unlikely, right? So how am I going to express this? I'll say it is possible that this prediction is incorrect. However, with 200 trials, it is likely to be accurate, or at least close. And I think what's important about this answer is that I make reference to the fact that if you have more trials, you should expect to be more accurate in your prediction. So, anyway, it was a bit longer than I wanted it to be, but that's my take on question 13 in your homework. I hope that helps. If there are other questions that you feel you'd like to see a video posted for, let me know, and I'll try to accommodate it. I try to either handle these things outside of class time, like at lunch. I can help you one-on-one, or I can post videos like this. There's a lot of stuff that we want to get through during class time, so homework issues I'd prefer to deal with in this sort of a way. Hope this helps. You know, the nice thing about videos being posted is that you can pause, take your own notes, you can rewind if it helps. Maybe I'll get better at it, and my videos won't be so long-winded. Thanks for watching. Talk to you later.